Great. So yeah, I'm Nathan from PickNik. We maintain the MoveIt open source motion planning framework. A lot of you are familiar with what we do. And I'm going to kind of talk about three primary topics. That is what's new in MoveIt, what's coming on the roadmap, and some of you may be hearing about what's Movelt Studio. So I'll start with what's new in Humble for MoveIt users. And there's a lot that's been going on. Some of you may already know from either the MoveIt community meeting in March or from ROS World. Some of this may look a bit familiar, but there's a lot of new stuff out there since we last had a meeting when we were all running on Galactic. One of the biggest things that we've done is a similar theme to a lot of people that have given talks is revamping our tutorials, really trying to get people to a point where they can move faster with ROS-I, and now MoveIt 2. So we've revamped all the content on the tutorial site. In particular, we found there were like different flavors of the style of tutorials, and it was probably confusing for some users as far as what to expect the tone of the piece to be about. So we've kind of re-architected all of this with this behavior-driven development as far as who the user is and what they want to get out of it. So we still have tutorials, but now these are now very specific walkthroughs on how to put together your MoveIt project or how to use a new feature. And then we have how-to guides, which are very specific targeted questions about how to use a particular feature. And concepts are more at an architectural level, just showing you how the pieces fit together, but not necessarily how to use them. So these might be more around our plugin structures and things like that, or just general high-level capabilities in a MoveIt package. Another newer thing that we've been working on lately is some getting started with MoveIt video series. So this is also a pretty cool feature. It's a video with a text annotation of the tutorials, just someone walking through the tutorials and what it looks like to get it ready on your machine. And in the event that you run into some sort of breakage, what it looks like to start contributing back to the project, open a pull request and say, hey, I ran into this issue with the tutorials. And is anyone else running into it? And how can I help merge it in? So all about making this more sustainable long-term and growing the user base for ROS-II and MoveIt 2, just the general ecosystem. So I encourage people to check out this new series. You know, these slides will be online with the links, or come find me during one of the breaks. So new features in MoveIt 2. We recently landed the MoveIt Setup Assistant port to MoveIt 2. And one of the things that took so long for us to get that ported was we wanted to get through all of the launch file best practices and tools. So how do we do Python through launch files? How do we do parameters, and how the new param server works for ROS-II? So I've done a little sample here. The main thing is that diff statement, huge reduction in all this code that you have to maintain and make sure is being standardized across your packages. Real easy to use. The MoveIt Setup Assistant uses it. Check it out. Second, we've also done a param builder that also simplifies some of your launch parameters, just decreasing verbosity, making it easier in how you load and propagate your YAML files and things like that. We have a repo in here with a few common example patterns of how to reduce your launch file syntax that you guys should also check out. And then this has already been discussed in a previous talk, but one of the big features we landed recently was hybrid planning. The big deal there is you can combine both your globally optimal planner that runs slowly with a local planner that does fairly local collision avoidance and get the best of both worlds. And you can now go and plan your welding path, for example, just in time for your local planner to then meet the velocity requirements or some of the lower level requirements that need to be performed at a high rate. So here you can go and mix and match different combinations of global or local planners for your general needs. This right now is still, we're still deploying it across new projects, and this is really the feature of the general framework of the hybrid planning. So we have a ROS World talk from 2021 that's on Vimeo, and the link's here if you're curious about more details there. And then this also is a feature that we showed off at ROS-Roll. We now support modeling planar joints such as stiff drive bases or holonomic bases in your robot model in MoveIt. So you can now plan your manipulation, your base together. And the nice thing about that is you no longer have to move and then pick and then move. And you can also reduce, depending on which global planar you use, you can reduce the number of joints you have to have in your arm or your application, which is going to be pretty important as these AMRs start to see manipulation capabilities. So you can now use the base as an extension of your arm instead of having to have what will then be redundant joints. So we did a great workshop that you can download the Docker image for. There's video of all of that on the web, and I provided the links here. And again, just stressing, like, we have a new feature, we have a new example, and we're really trying to make sure that we add the documentation as these new features land. A newer feature is we now have trajectory jerk smoothing. This has been a big request from pretty much everyone in the industry working with big arms or really trying to push the limit while not killing their hardware. So we're using an open source package called Ruckig, which is German for jerk, and it does jerk smoothing at the trajectory level. It's a one-line change. It runs after all your time parameterization. And there's some nice stats here from the maintainers of Ruckig as far as like you can run this very quickly in the loop. So there's also been some investigation into running this at a visual server weight level and not just at a trajectory parameterization level. So if you're working with large equipment, you can go and dynamically change where these limits are depending on what your payload is, which is also really nice for maximizing your cycle time while preserving the life of your hardware and not shaking it to death. This one's a little more straightforward, but great excitement to a lot of the community. The Pills Planar port has landed. All your linear and your circular motions that you want to have determinism around how they're going to do those moves, and the blends is now available in ROS-2 and MoveIt 2. And we have an example about how to set that up for your MoveIt motion planning pipeline. And then I said, MSA is 95% there. The last little bit that's merging in is the automatic setup of your ROS-2 controllers file. But aside from that, we've got it all set up nicely. David Liu put a lot of work into making this even more modular than it was before. And there's a feature branch you can try out right now with the last missing bit available. So again, there's some tutorials on the feature branch as well, kind of walking you through how to use the MoveIt Setup Assistant to configure your ARM from a SolidWorks file or a CAD file and end up with the URDF package that you can directly start running MoveIt examples from in RViz or MoveGroup or MoveIt CPP. And this is the big thing that a lot of other people have been talking about as well. We've seen huge progress in the last year on ROS-2 control ARM drivers. We've worked with Universal Robots to officially release and have them maintain a ROS-2 driver. Franco's released their own as well. And there's been a lot of community development around starting some new interfaces. In particular, there's a few different methods for KUKA ARM control. And just this morning, we released a public announcement of a ABB ARM driver, thank you, Kat, that we developed with a commercial partner, OptiMax Systems, which they do a lot of complicated optics manufacturing and polishing. So they're using this, you can read about it online, for some pretty cool optics applications. And then there's other work going on, as you guys heard earlier. And Kat and Sean and myself personally went to every single booth at Automate and asked them, what's your knowledge on ROS? What's your plan for ROS-2? What's your timeline? And looking forward, what we'd really like to see is more and more of these ARMs have the capability to run their drivers on board the machine and make the setup even less painful. And some other resources, obviously, please reach out to us if you're interested in learning more about how to set up a ROS-2 driver, or companies that are looking for help with that. But we have a couple different talks here. We have this lightning talk that one of our devs put together that was just a 2-minute high level, here's how you write a driver. And we also have a more extensive ROS world video about the more involved features that we worked with Universal Robots for on their driver. And hoping to have some pretty exciting announcements in the near future about some additional driver support. So MoveIt roadmap. Lots happened last year, a lot's going to happen this summer. We're pretty excited. So something we get a lot of questions about very routinely is, why is my Cartesian planar doing weird things? Why is it failing? And I'm happy to say we both have, we have two different ways we're going to soon be tackling, or we're actively tackling, and we'll be having solutions for in the near future. We are finishing out the work we started a couple last summer around the constrained OMPL features of the constrained planning features of OMPL. So these would be globally optimal solutions where you can add constraints in position or orientation or any other space that you can define and get some really great results. And similarly, BioIK is something we've used very effectively, in particular as a local planner, where you can also describe some constraints and optimization functions a number of different ways. So this is this bit here is from the constrained OMPL planning, where we have a box here. We say we want the end effector to be within that box volume, but aside from that, we want the fastest path in joint space. So these are hopefully going to land towards the end of the summer or sooner, and we'll have some public release announcements and some tutorials talking about how to use these and when to use these. And other work going on this summer is we're really excited that we were accepted to 2 Google Summer of Code students. We finally found the right person who both knows the MoveIt CPP and is excited about the possibilities of the Python bindings for machine learning or quicker starts for people that want to use a Python interface. And we're working on the Python bindings for MoveIt too. So that's an exciting feature I know a lot of people have been waiting for. And a second feature that we're working on is the industrial assembly challenge that the University of Osaka worked on, and Christian's going to work on getting that merged into MoveIt too. So now you can actually have first-class support for dual arm applications where you can actually have 2 different explicit trajectories running at the same time. So we're seeing this a lot from our customers who are trying to increase their pick rate by adding a second arm. And some of the workarounds everyone's been having to do for that, which reduce the cycle time, we'll be able to get around that. Other things on the roadmap are we are finding ways to implement best practices, both in parameter loading and just in general within the MoveIt code base. And excited to talk with Kat's team and everyone else about their efforts there, making this more maintainable as we've gotten through the humble release, we've gotten the core features done. How do we make it more reliable long term and continue to make it very painless as these upgrades come up? Another feature that I'd love to hear if other people are really excited about this, but the ability to dynamically load your URDF model. So better support for attaching and detaching into vectors is another thing on our roadmap. I'm seeing some people nodding right now. So I will talk with you all later about the timeline for that and some of the current capabilities we have. And then again, ways to begin getting involved. There's a number of ways. Obviously, we want more people improving and fixing the documentation. There's new users every day. You know more than you think you do. And there's always people that were, where a new user was 3 months ago, there's someone there now. So if you're a more comfortable user, like I said, we have 2 interns this summer doing great work. We have 2 Google Summer Code students as well. There's always new features that we can pair our MoveIt mentors and developers on to add more capabilities. So now I'm going to talk a little bit about MoveIt Studio. Everyone in this industry is trying to figure out how do we get our talent to be more effective, or how do we clone some of our more talented developers? And we can't do that second one quite yet, but we are working towards the first one. And Movelt Studio is a premium add-on on top of MoveIt, on top of the ROS-I ecosystem that we've been developing for the last year and a half with some commercialization grants. So just like MoveIt and just like ROS, it's hardware agnostic. It's all extendable via plugins. But really what we're looking for here is to kickstart everyone's development and make it less painful to get to their client application and validate some of their hypotheses about what actually needs to get done. So there's a few components to Studio that build on top of the MoveIt stack. The biggest one here is an SDK that we've seen 70, 80 companies, how they use MoveIt, how they use the ROS ecosystem. And more we're seeing behavior tree frameworks being used. And rather than each company building their own SMAC or their own behavior tree implementation, we built a behavior tree framework with manipulation explicitly in mind that people can build off of. And common behaviors like planning or execution with recovery features that you don't then have to build and maintain. And I'm seeing this as a common pattern here today, fine-tuning your system by not restarting or recompiling by exposing some of the parameterization into text files, JSON, YAML, things of that nature. So we've been using this with some people, and that by itself is very powerful, being able to just tweak your system and tell the behavior, that section of the behavior tree or your state machine to run again. So here's an example of kind of how we parameterize some of this stuff, and it's a pretty powerful mechanism where you can use one high-level behavior tree with a lot of recovery features and use it for something like plugging in a fuel hose or pushing buttons with variable stiffness and things like that. So at the text file level, we can very quickly say what defines success for that task, how far it needs to go, and how much force it should expect before it airs out. And then I mentioned, how do you get to robustness more quickly? Something else we've been working a lot on in the last year is a set of web tools that can be used during development to really focus on how to debug your manipulation application. So we have a web editor and a monitor for your behavior tree library. So you can see where it's airing out. You can share a screen with another developer and have them look at what your behavior tree looks like. And maybe there's some settings you might need to change. Again, all this is web tools, so you can preview the motions after you've changed the parameterization files. Lots of things that we've come to expect as far as bag files, storing them, retrieving them, stepping through them. And something that we've been focusing more on with our remote development team is testing the hardware remotely for your new feature. And if you accidentally drive it into something or your feature is a little too aggressive, clearing your protective stops and moving your arm safely out of whatever collision it might be in. So you don't have to have someone or go walk over there to clear your piece down. And then the last bit here, which was developed mainly for a NASA SBIR as part of a commercialization strategy there, is a supervised autonomy web framework called Studio Supervisor. We've found this to be useful in a lot of applications, but in particular, NASA is interested in these supervised autonomy frameworks for their Artemis program, where there's a significant time delay for the lunar space station or even the ISS, where they want to perform tasks remotely using a robot, but teleoperation isn't going to cut it, and it's too life critical to fully trust the autonomy at this point in their technical readiness level. So Studio Supervisor is a way to give the operator situational awareness as far as what's going on, use human guidance, and then monitor the execution as it goes on. And a nice benefit of this is this also allows for terrestrial clients to use the supervised autonomy framework to incrementally reduce the amount of intervention required there. So I've got a short example here of a simple door opening application, but the supervised autonomy here is maybe there is not sufficient AI or CV to recognize all the door handles you might encounter. I was talking with someone yesterday about machine tending applications and how you might use this for tending to a machine and fixing if a door is jammed or something like that. And you might need some supervised level of autonomy if you haven't seen that door handle before until we get more into learning frameworks that would unlock that. And with that, don't want to block people from lunch. That's never a good idea. So how much time do we have for questions?
A few minutes. Any questions for Nathan? Nathan, thank you.
Yes.
You mentioned that you guys did kind of an informal survey of the exhibitors that wanted to. Are you able to just publish that? Or
That's a great question. The question is, I mentioned I had talked with pretty much all the. I almost talked with all of them personally, but collectively we've talked with every arm manufacturer that was on the floor of Automate, and can we write something about what our findings were? Absolutely, I think that's a great idea. I'm probably going to spend most of next week on calls with a lot of them, so I want to see where we end up there, and I'm hoping in 2 to 3 weeks we can have some informal results.
Anything over here for Christoph? Question. If you want to test the studio.
Yeah, come talk. Yeah, so Christoph was asking if there's a way for you guys to test out MoveIt Studio, and the answer is yes. I have my laptop, and I think the network here is better than the Automate network. So yes, come find me during the break.